Thanks for attending. Welcome to SREcon Asia. My name is Andrew Ryan. I'm a production engineer at Facebook, where I've worked since 2009. Been in a couple different teams there. I currently work on the traffic infrastructure team, where I help support our Edge Pop network, as well as our global traffic routing systems. And today we're going to be talking about testing, as you might have guessed. Specifically, what I'm calling fast and cheap testing, the type of software testing, infrastructure testing that we can do quickly and easily and provides a lot of bang for the buck. In my years as a production engineer, sysadmin, programmer, I've been doing this almost 20 years. There's always, I think, room for us to do more testing, and I think there's a sort of some cultural barriers in our profession that have kind of kept us historically from reaching our full potential. But I'm really excited by all the stuff that I'm seeing here. I think we're really headed in the right direction. So let's look at some code. We all write buggy code sometimes. Here's an example. So here's some code that calculates a packet rate, given a counter value now and a counter value 5 minutes ago. Let's calculate the rate, do subtraction, division. And this code will compile and run just fine, but it has bug, right? Because what if, in this case, packets now is equal to packets 5 minutes ago? Well, in that case, rate hasn't been initialized. We're going to get a name error. Our script's going to crash, okay? So a little bit of a simple, contrived example, but you can see the point. We're going to get, it's going to fail. And then, of course, we can have some of these bugs which are really, really bad. So take a look at this bash script where we define some temp directory, we write to it, and then at the end of it, we decide we're going to clean it up, except that $temp evaluates to nothing, and we do rm-rf/star. Oops, right? Again, contrived example, but I'm sure we've all seen at some point things like this happen in code that has been out there in production. So just like we all know that eating broccoli is good for us and vegetables, right? We all know that we should be doing more testing, right? Testing is good. Nobody argues for less testing usually. It's pretty rare. But most of us, like we don't eat enough vegetables, we also don't do enough software testing. So my goal for today is to get you to be thinking about software testing and infrastructure testing just like eating a delicious donut. Something which is easy to do, yummy, and rewarding. And yes, we will have donuts. Good. I think production engineers and SREs have a historical kind of problem. At least this is what I've seen in the groups that I've worked in across many companies and many teams over the years. So let me run through some of the lame excuses that I've personally used and seen from others. Like, it's just a shell script, right? Oh, it's little. It's not going to, it's not going to cause any harm. Doesn't need to be tested. Or I don't have time. I don't know how to write tests. This is a pretty common theme where people are just not familiar with the art or science of test writing. Or they feel like they don't have time because they have to push this fix out to production to unbreak something. Another one that I've heard before is people saying I'm not a software engineer. And so therefore, software engineers do stuff like write tests, and production engineers or SREs or sysadmins, whatever, we get stuff done, or but I'm really glad to see this is changing, but it's definitely been something that I've heard over the years. Another favorite, I ran it. It seems to work. Of course, running it is a form of testing. You have run it, it has been tested, but as we've seen from the examples earlier, it's possible to run something under some conditions and it works, and while other conditions it fails spectacularly, so not sufficient. And finally, I think one that's really valid for type of work that we do as production engineers is that a lot of our code has external dependencies. We're talking to web services, we're talking to remote hosts running commands on remote hosts. Maybe we're doing destructive or mutations on a database or a file system. And these things can be difficult to test in the real world. So we'll talk about how to address all of these throughout the subsequent parts of our talk. So there's a lot of types of code that we write as production engineers. There's a lot of types of testing. Because we only have 20 minutes, we're going to not talk about all of them, but I wanted to pick the 3 types of code that I think are most common for production engineers and most easily tested. And we're going to talk about those in detail. The first one is shell scripts. Need no introduction. The second one is what I'm calling tooling, written in languages such as Perl or Python or Go or Ruby. And this would include more advanced monitoring scripts, maybe deployment scripts, the type of monitoring deployment scripts that we're typically writing as production engineers. And then lastly, configuration management. So Chef, Puppet, Ansible, CF Engine, all these types of configuration management systems that have you writing code to configure your systems in the way that you want them to work. All right, so let's get right into it, starting with testing shell scripts. My #1 piece of advice is not to write shell scripts. But sometimes you don't have a choice, and sometimes there's a valid reason to write a small shell script, but other times you are stuck with a bunch of legacy scripts that you can't easily unwind or replace with something better. So if that's the case for you, if you must write shell scripts, my first suggestion is to protect yourself at runtime with -u and -e when you're invoking bash. So -u will error out on any unset variables. In our example earlier, that would have made the rm command fail because $temp wouldn't have been defined. And -e to exit if any command anywhere in your script exits non-zero. You can still catch errors and keep going, but if you encounter an unexpected error, it'll stop your script. So it's a useful abstraction at runtime. But we'd like to prevent bugs from even getting into our code. Runtime is not the best place to catch them. And that's where linters come in. Linters are wonderful, and there's a really good shell linter called shellcheck. If you haven't used it, I definitely recommend check it out. It's at shellcheck.net. And you put in your code. So in the example up on the board, that's the code from the first slide. And shellchecker will tell you temp is referenced but not assigned. So even before you run it, shellcheck sees that you've used a variable that hasn't been defined and it's complaining about it. So linters, really good. Shellcheck, thumbs up. Now, I believe if you're writing unit tests for shell scripts, you've kind of already lost the battle, and you're probably better off switching to a more powerful and expressive language like Python or Ruby or Go or one of those. But maybe you have some legacy code that you can't easily rewrite. And in cases like this, there are 2 unit testing tools that I'm aware of for bash. One is called BATS, the other one is called SHUnit2. Disclaimer, I've never used either of these personally, but they have active user communities and documentation and source code, and so they seem to work. So if you have to write unit tests, these 2 work. And we'll talk more about unit tests detail in the next section when we talk about testing in Python. So all the stuff I'm going to say is about Python, but there's equivalents in all the other major scripting languages, Ruby, Go, Perl, whatever you're using. The names will be different, the syntax will be different, but hopefully you should get an idea of the capabilities and what we're talking about. So the first thing, lint, right? Back to the shell checker example. Python also has some really good linters. These are 3 that I'm aware of that are all in wide use, Flake 8, Yap, and PyLint. At Facebook, we use Flake 8, but lots of other organizations use other ones. You should try them all and see which ones you like. All of these can be integrated and should be integrated into your text editor. So you can have them running in Vim or Emacs, even while you type. So as you're typing lines of code, these lint checkers will see what you're doing, analyze your Python, and tell you if you have mistakes or if you're doing things that aren't either syntactically or stylistically valid. It's really like having a senior programmer leaning over your shoulder at all times who never makes a mistake and always knows the right thing to do. So lint is great. Next up is unit testing. So for those of you who have never written a unit test or who aren't familiar with it, the basic idea is that we take our function and we run it a bunch of times with various input, and we validate that the input plus the function produces the output that we expect. So some sample Python here that would be a unit test for this function here. We define a class called here test calc rate, which inherits from the unit test case module. Inside of that, we have one or more test functions, and then inside of that test function, we run a couple of commands. And as you can see, we're running the actual function, calc5minrate, with a few different sets of arguments. So we have our normal, in the first case, where we have the normal positive case where the bytes now are greater than the bytes 5 minutes ago. Then we have the case where somehow we've gotten a negative, and that's also going to pass. And now here we have our case where bytes now is equal to bytes 5 minutes ago, and that is going to, or packets, excuse me, and that's going to fail, right? So we would see that through the unit test, our code would fail if, by some chance, packets now and packets 5 minutes ago were equal. So unit testing isn't only useful for things like this to find bugs in your code. It's also really, really useful when you are refactoring and making, for example, changing the order of the function arguments or adding additional function arguments. If you're ever going to change your version, for example, of Python or whatever language you're using, this is super essential. Facebook just did a talk this week at PyCon talking about Instagram's Python deployment and how we've just moved all of Instagram from Python 2 to Python 3. It's a lot of Python code, and it would not have been remotely possible without a lot of unit testing in place, and unit testing found a lot of bugs during that process. So unit testing, a really good thing to do. One additional benefit of unit testing is that it changes the way that you write code. What do I mean by that? Well, in order for you to be able to construct a unit test, you have to have a relatively simple function that takes some straightforward arguments and outputs some straightforward results. If you're writing functions that are really long, have a lot of branching, or take all kinds of variable input or produce all kinds of variable output, it's going to be you're going to find it's very difficult, if not impossible, to write unit tests for that function. You're going to probably, tear your hair out. Actually, what you're probably going to do is realize that you have to refactor those longer functions and turn them into shorter, more decomposable functions. So not only does unit testing give you better software, testing and quality there, but it also makes your code easier to write. We talked about how production engineers are often writing code that has a lot of external dependencies, and those external dependencies can be things like third-party servers or mutations on databases, mutations on file systems. Those can be difficult to test, right? Because we don't want to go actually out to the file system and remove stuff. So take a look at this function, which is called temp cleaner, trivial function that's just running shelling out to run a rm minus rf of temp foo star. Okay, so really simple, basic function. But to test this, if we were to test this and run it, what would it do? Well, it would actually remove any files, name/temp/foo star on our local file system, which might not be what we want to do every time we run the test. And to get around this, we use something called mocks. You'll also hear these sometimes referred to as fakes. And the general idea of a mock is you take the thing that is the external dependency, the thing that you want to under test, and you replace it with this thing called a mock, which sort of looks like in this case, subprocess.checkoutput, but it doesn't actually do anything. So the mock version of subprocess.checkoutput is not actually running an RM, but you can do things like, in this case, you can run this method assert called with that makes sure that we are actually invoking subprocess checkoutput with the arguments that we expect. So this is a useful abstraction, and this is a very simple example, but you can see in the general case how you could replace, for example, connections to databases or remote SSH commands, all sorts of things that we as SREs, production engineers, have to do in our daily work. Also, it's not a replacement for functional testing, right? Because we still haven't verified that this actually does what it's supposed to. You'd still need to functionally test this program and make sure that it actually invokes the RM command and removes files that look like temps foo. But this is a good start for unit testing, and it's a good example of how mocks can help us test. So for the last section, we're going to talk about testing in Chef. Now, most of what I'm saying applies to other configuration management systems, as far as I know, although I'm not as familiar with them as I am with Chef. So if you use Puppet or Ansible or CF Engine or one of those others, there's probably some equivalents. We'll just be talking about Chef since that's what we use at Facebook and that's what I'm most familiar with. So let's get something out of the way first. Configuration is code, okay? Over the years, sometimes I hear people say like, oh, well, it's, we don't need testing for that because it's just a Chef diff, but on the other hand, like how many Chef diffs have, brought down services at Facebook? A lot over the years, and probably will do even though we have pretty decent testing. So let's get it out of our heads that, there's some delineation between like code that we write like for standalone programs or web services and then configuration management systems, right? It is code, it can be tested, it needs to be tested with the same rigor that we use for any other software. Not surprisingly, the first thing I'm going to recommend for fast and cheap testing of Chef code are linters. And Chef has two linters, and you need to use them both. The first one is called Rubocop. It's a general Ruby linter. It's very similar to what Flake 8 and Pylint provide, general Ruby style and syntax and kind of enforcement of what's the rules of the language. But Chef is a specific dialect of Ruby, has its own gotchas on top of Ruby. So for example, it's possible for you to write syntactically valid Ruby that will not do anything approaching what you want in Chef. That is why we have a second linter called Food Critic, which gives you Chef-specific Ruby style advice. These are both open source. You can download them, integrate them into your workflow, and they will help you avoid many of the common mistakes that you might make in Chef. You can also write unit tests for Chef cookbooks. Facebook has released a number of open source cookbooks on GitHub, and all these have unit tests attached to them. So here's an example of a simple unit test for a systemd calendar library. You can see, again, it's basically just checking some input and making sure that it produces the expected output. So when you're writing Chef cookbooks, you can and you should be writing unit tests for them. It's a simple thing and adds a lot of quality assurance to your work output. The last step to testing Chef is testing the actual bundle of Chef changes on a real server. So this would sort of be like a canary, you might call it like a canary deployment on 1 or 2 servers. And to do this, we have a tool called Taste Tester. Again, built at Facebook and open source. So if you use Chef, you get this for free. What Taste Tester does is it packages up the entire, your entire Chef diff or set of changes and pushes it to 1 or more servers for a specific amount of time, and then you can run your tests on the Chef server that's under test and see if it produces the expected result or doesn't break anything, whatever, and then deploy to check it into the whole world or deploy it out however you'd like to. In addition to Taste Tester, when you're using a configuration management system, another really good pattern is to gate your changes using conditionals. So for example, you can just wrap changes in something like an if block where if host name is this, or if rack name is this, or if cluster name is this, then apply my change there. And that way you can incrementally roll out changes and test things on a small scale before sending them to the entire world. So these are techniques that we use at Facebook for pushing out our Chef changes. Like every Chef diff has to go through both linters, and every Chef diff has to be taste tested on at least 1 host. So that concludes our discussion of specific testing methodologies, but in the short time we have remaining, I'd like to talk about some of the ancillary benefits of testing and how now hopefully that you're energized to do more testing, can be a test champion inside of your organization. We all like free stuff, and it turns out that you get a bunch of stuff for free when you start adding even simple testing like I've described here today. So one benefit is recruiting, both internally and externally. In my experience, and I've done a lot of recruiting at Facebook, good people are more likely to want to join your team when they see that the quality of your code and your infrastructure is good. The second area is around training and ramp up of new employees. When new people start in your team and you don't have enough testing in your team, it's very difficult for them to get started, because any change they want to make to production is going to be risky or dangerous, right? When I was on one team at Facebook, it took us 6 months to get a new engineer on call because there was so much training and it was so dangerous, and if you touch the wrong thing, you take down the site. Or through testing and through additional documentation, we were able to get that time down to 3 months. So real improvements from just adding additional testing and additional rigor around pushing out changes. Lastly, let's talk a little bit about people. So you have interns, for example, and contractors, and employees that aren't going to stay around forever. You know this. And just in general, like nobody stays at one company forever. Very few people do. Without tests in place, deep knowledge of the workings of the code that they've worked on leaves when the employee leaves. And that's a bummer. So people come and go, but a good test lasts forever. And if you make your employees, and especially your interns and your contractors, write tests, when they leave, their code's going to stand the test of time, or at least be a lot easier to fix and maintain because they've left tests behind. Okay, so now that you're personally excited about testing, my hope is that you'll go back to your workplaces and become test champions. Bring these delicious donuts to all of your coworkers. So how do we do that? 3 simple things. First one is lead by example. Write tests for your own code, okay? If you're not testing your own code and you're just saying other people should do it, that's not good. The second thing is to make it easy. These tools that I'm talking about, make sure they're installed on people's dev servers. Make sure people understand how to integrate linters into their Vim RCs and their .emacs files, right? Make sure you have documentation and examples for people that want to write tests. And lastly, be pragmatic. Trying to push too much testing too quickly on a team that hasn't done it before can lead to a lot of pushback and sometimes some bad feelings. So in my experience, it's best to start small, and as people start to realize the real benefits of testing, they're going to become believers, and eventually they're going to become fully embracing the test methodology. So you don't need to push people super hard. Be pragmatic about what you can achieve. Now, we've only scratched the surface of testing. There's a really good chapter, for example, in the Google SRE book that covers all the types of testing that you could ever possibly do. But two things that I'm going to suggest as next steps if you're interested. One is integrate your testing with code review tools. So at the time when you're approving a diff, you should have already seen the test results, ideally, that this diff is not going to break anything and it passes all of our lint checks. And then integration with CI, continuous integration tools. So whether you're using Jenkins or Travis or Kitchen CI or Server Spec, these are all tools that will take any change that gets made in your infrastructure and make sure that it works on a variety of environments, in a variety of situations. Really good next step if you're interested in taking your testing to the next level. So hopefully you are now believers in testing as delicious donuts. I'll be happy to take questions at the mic, or you can see me afterwards and have some donuts.